Hello. To have limitless technology on Earth depends on some mathematical problems. What problems are we talking about? We are talking about the Millennium Prize Problem. Wow. These problems have been available like 100 years ago and it has been remained unsolved. What? The initial of the problems they were collected together by the Clay Mathematics Institutes in 2000 and they put a price tag of $1 million. $1 million on each problems that you can solve. And these problems alone, if you can provide each solution a correct solution, which should be verified, you can just give anything. So they provided solutions, and six of them are still remain unsolved of seven. The only one that was solved by a Russian. There is a mathematician, the Poincare conjunction. It was solved, and this man rejected and he refused to collect the $1 million. Why? Okay, all remains to him. He has his own issues with that, but he's a great man and he solved the problem. Okay, so what are we having left on the list? We have the Bash and Sweden Dyer conjunction, Hodge conjunction, Navier-Stokes resistance and smoothness, P and versus NP problems, and Riemann hypothesis, and we have the Jean-Miles existence mass gap. Wow, these are great problems. So at the meeting held in 2000 March 24, the official websites have collected the problems together and they put the price as I have said. And the Russian mathematicians, the great man that solved the Poincare conjunction in 2010 was Grigor Perelman, and okay, he declined the $1 million. So that's my problem with that. Okay, so we'll be starting with the point care conjunction, which was solved recently, and it's not in a simple. We won't bore you with mathematical terms too much, but it's just like you blend a pyramid from plasticine. Like for example, when you have a paper that is round that you cut circular, and you can fold it into cone, into cylinder, and even into sphere without gluing or tear anything apart, just simple like that. Or better still, another example is like when you blend a bangle and you can succeed in the trick by just deforming it and maybe into a cup with an handle. Then the surface of the sphere and the cylinder is just an homomorphic, and while the surface of the sphere and the torus are non-homomorphic. So this is just a simple case of Poincare, and it is showed that there will be a hole inside the two-dimensional, which is homomorphic to a two-dimensional sphere. So it's very simple. So that's just what, in a simple translation of what the Poincare conjunction is. Okay, now let's start with the unsolved problems, which we are still waiting for solutions for any mathematicians that can solve it. So we'll be starting with the P versus NP problem, and this problem is from the field of complexity algorithms. Okay, so talking about the P versus P NP problem, the P problem is just problems that can be solved in the n polynomial time. That is, you can solve the problem in n polynomial time, and NP problems are the ones that you can confirm the solution in n polynomial time. Example of P problem is just like a simple quadratic equation or just a linear equation, maybe 3x plus 2 equals 6, something like that. That's problems. And NP problems are the ones that maybe like you want to confirm the combinations or password of your friend to his phone or her phone. So something like that to confirm a solution that is available before with someone, and you want to use you don't know the password, but you just want to guess the password. So it's just an NP. So imagine something like P. So you have some category of people that said, okay, the P problems is the same thing as NP problem. problems, and there are ones that said they can never be equal. So, and some said if they are equal, it will be a great breakthrough. Imagine that. So having a combination to our password is the same thing. Guessing a combination to a password is the same problem of solving a linear equation. Do you know that will be a great breakthrough in the field of algorithm development, and that will be a very breakthrough in the field of algorithm development. So can you see, if imagine these problems are solved even before the next 5 years, how can you believe what will happen to planet Earth and how much advantage this will bring to us? You can be the one, if even if you don't want the $1 million, just like Grigor, $1 million, even like Grigor Perlman, you can solve the problems to save the Earth and help us all to solve a lot of these problems. Thank you. We are waiting for you and hoping that you will be the next man to win the prize.